Hello friends and welcome. In today's lecture, we shall talk about fats and oils. The main objectives of today's deliberation are to provide a general introduction about fats and oils, followed by understanding the chemical composition of fats and oils. We shall also classify fats and oils and try to look into the various processing methods and reactions of fats and oils. And finally, we shall talk about the importance of fats and oils. To begin with, let me give you a brief introduction about fats and oils. Fats and oils are constructed of building blocks called triglycerides. Fats and oils are formed by the combination of 1 unit of glycerol and 3 units of fatty acids. They are insoluble in water but soluble in most organic solvents. They have lower densities than water and may have consistencies at ambient temperature of solid, semi-solid or clear liquid. When they are solid appearing at a normal room temperature, they are referred to as fats. When they are liquid at that temperature, they are called oils. For simplification purposes, the terms fats and oils are used interchangeably in the remainder of this topic. Now, let us shift our focus to the chemical composition of fats and oils. The main components of edible fats and oils are triglycerides. The minor components include mono and diglycerides, free fatty acids, phosphatides, sterols, fat-soluble vitamins, tocopherols, pigments, waxes, and fatty alcohols. The free fatty acid content of crude oil varies widely based on the source. Other than the free fatty acids, crude vegetable oils contain approximately 2% of these minor components. Animal fats contain smaller amounts. Now, coming to the major component, that is triglycerides. A triglyceride consists of 3 fatty acids attached to one glycerol molecule. If all 3 fatty acids are identical, it is a simple triglyceride. The more common forms, however, are the mixed triglycerides in which 2 or 3 kinds of fatty acids are present in the molecule. Moving on to the minor components. Mono and diglycerides. Mono and diglycerides are mono and diesters of fatty acids and glycerol. They are used frequently in foods as emulsifiers. They are prepared commercially by the reaction of glycerol and triglycerides or by the esterification of glycerol and fatty acids. Mono and diglycerides are formed in the intestinal tract as a result of the normal digestion of triglycerides. They occur naturally in very minor amounts in both animal fats and vegetable oils. Oil composed mainly of diglycerides has also been used as a replacement for oil composed of triglycerides. One of the minor components of fats and oils is the free fatty acids. As the name suggests, free fatty acids are the unattached fatty acids present in a fat. Coming to phosphatides, which are also known as phospholipids, they consist of an alcohol, usually glycerol, combined with fatty acids and a phosphate ester. Moving to sterols, they are found in both animal fats and vegetable oils, but there are substantial biological differences. Cholesterol is the primary animal fat sterol and is found in vegetable oils in only trace amounts. Vegetable oil sterols are collectively called phytosterols. Stigmasterol and cytosterol are the best known vegetable sterols. Cytosterol has been shown to reduce both serum and LDL, low density lipids, cholesterol when incorporated into margarines and or salad dressings. The type and amount of vegetable oil sterols vary with the source of the oil. Tocopherols and tocotrienols are important minor constituents of most vegetable fats. They serve as antioxidants to retard rancidity and as source of the essential nutrient vitamin E. Coming to the last minor component, that is fatty acids. They are long-chain alcohols and are of little importance in most edible fats. A small amount, esterified with fatty acids, is present in waxes found in some vegetable oils. Larger quantities are found in some marine oils. Tocotrienols are mainly present in palm oil and can also be found in rice bran and wheat germ oils. Let us now shift our focus to classification of fats and oils. First, a general classification of fats and oils. Triglycerides are comprised predominantly of fatty acids present in the form of esters of glycerol. Both the physical and chemical characteristics of fats are influenced greatly by the kinds and proportions of the component fatty acids and the way in which these are positioned on the glycerol molecule. The predominant fatty acids are saturated and unsaturated carbon chains with an even number of carbon atoms and a single carboxyl group. Coming to the main classification of fats and oils. Fatty acids occurring in edible fats and oils are classified according to their degree of saturation. First, saturated fatty acids. Those containing only single carbon-to-carbon bonds are termed saturated and are the least reactive chemically. Second, unsaturated fatty acids. Fatty acids containing one or more carbon-to-carbon double bonds are termed unsaturated. When the fatty acid contains one double bond, it is called monounsaturated. If it contains more than one double bond, it is called polyunsaturated. Conjugated fatty acids are polyunsaturated fatty acids in which at least one pair of double bonds are separated by only one single bond, while as non-conjugated fatty acids have one pair of double bonds separated by two single bonds. Number 3. Polyunsaturated fatty acids, that's PUFAs, are fatty acids that contain more than one double bond in their backbone. Of the polyunsaturated fatty acids, linoleic, linolenic, arachidonic, eicosapentaenoic and docosahexaenoic acids containing respectively 2, 3, 4, 5 and 6 double bonds are of most interest. Now, moving on to the next segment, that is the isomerism in fats and oils. First of all, we should know what isomers are. Isomers are two or more substances composed of the same elements, combined in the same proportions but differing in molecular structure. For simplification process, the example of N-pentane is given with its different isomers having same carbon and hydrogen but differing in molecular structure. Having understood what isomers are, let's highlight the types of isomerism found in fats and oils. Fats and oils show two types of isomerism. Number 1. Geometric isomerism. Unsaturated fatty acids can exist in either the cis or trans form, depending on the configuration of the hydrogen atoms attached to the carbon atoms joined by the double bonds. Number 2. Positional isomerism. In this case, the location of the double bond differs among the isomers. Before proceeding further, one must know what omega fatty acids are. A class of essential fatty acids found in fish oils, especially from salmon and other cold water fish, that acts to lower the levels of cholesterol and low density lipoproteins in the blood. LDL cholesterol is the bad cholesterol. Some important omega fatty acids are eicosapentaenoic acid, docosahexaenoic acid. Let us now move on to important part of our discussion, that is the processing of fats and oils. First of all, let us talk about the general processing of fats and oils. Food fats and oils are derived from oilseed and animal sources. Animal fats are generally heat rendered from animal tissues to separate them from protein and other naturally occurring materials. Rendering may be accomplished with either dry heat or steam. Vegetable oils are obtained by the extraction or the expression of the oil from the oilseed source. The fats and oils obtained directly from rendering or from the extraction of oilseeds are termed crude fats and oils. Crude fats and oils contain varying but relatively small amounts of naturally occurring non-glyceride materials that are removed through a series of processing steps. Moving on to the next processing step, that is degumming. The process generally involves treating the crude oil with a limited amount of water to hydrate the phosphatides and make them separable by centrifugation. For fats obtained by pressing and water which are low in phosphatides, 20 parts per million of phosphorus, such as palm oil, palm kernel oil, olive oil. The degumming process is quite simple. It suffices to mix the fat with a small quantity of a strong degumming acid such as phosphoric or citric acid to dissociate the non-hydratable phosphatides NHP into phosphatidic acid, that is PA, and calcium or magnesium biphosphate salt. Both components are removed by adsorption on bleaching earth in the so-called dry degumming process. A relatively new process in the United States is enzymatic degumming. An enzyme, phospholipase, converts phospholipids present in crude oil into lysophospholipids that can be removed by centrifugation. Crude oil, pretreated with a combination of sodium hydroxide and citric acid, is mixed with water and enzymes, for example phospholipase, by a high shear mixer, creating a very stable emulsion. The emulsion allows the enzyme to react with the phospholipids, transforming them into water-soluble lysophospholipids. This emulsion is broken by centrifugation, separating the gums and phospholipids from the oil. This process generates a better oil yield than traditional degumming or refining. Next, neutralization. The process of neutralization, sometimes referred to as alkali refining, generally is performed on vegetable oils to reduce the free fatty acid content and to remove other impurities such as phosphatides, proteinaceous and mucilaginous substances. Now, let us move on to one of the important processing methods of fats and oils, that is bleaching. The term bleaching refers to the process for removing color producing substances and for further purifying the fat or oil. Normally, bleaching is accomplished after the process of neutralization. The usual method of bleaching is by adsorption of the color producing substances on an adsorbent material. Anhydrous silica gel and activated carbon also are used as bleaching adsorbents. Moving on to the next processing step, that is deodorization. Deodorization is a vacuum steam distillation process for the purpose of removing trace constituents that give rise to undesirable flavors, colors and odors in fats and oils. Normally, this process is accomplished after neutralization and bleaching. The deodorization of fats and oils is simply a removal of the relatively volatile components from the fat or oil using steam. Deodorization is carried out under vacuum to facilitate the removal of volatile substances, to avoid undue hydrolysis of the fat, and to make the most efficient use of the steam. Deodorization does not have any significant effect upon the fatty acid composition of most fats and oils. Depending upon the degree of unsaturation of the oil being deodorized, small amounts of trans fatty acids may be formed. In the case of vegetable oils, sufficient tocopherols remain in the finished oils after deodorization to provide stability. The next method involved in processing of fats and oils is fractionation, including winterization. Fractionation is the removal of solids by controlled crystallization and separation techniques involving the use of solvents or dry processing. Winterization is a process whereby material is crystallized and removed from the oil by filtration to avoid clouding of the liquid fraction at cooler temperatures. Moving on to the partial hydrogenation or hydrogenation of fats and oils. Hydrogenation is a process by which hydrogen is added to points of unsaturation in the fatty acids. Hydrogenation was developed as a result of the need to: number first, convert liquid oils to the semi-solid form for greater utility in certain food uses. Number two, increases the oxidative and thermal stability of the fat or oil. It is an important process to our food supply because it provides the desired stability and functionality to many edible oil products. In the process of hydrogenation, hydrogen gas reacts with oil at elevated temperature and pressure in the presence of a catalyst. The catalyst most widely used is nickel, which is removed from the fat after the hydrogenation processing is completed. Another process used by oil processors is interesterification. Interesterification causes a redistribution of the fatty acids on the glycerol fragment of the molecule. This rearrangement process does not change the composition of the fatty acids from the starting materials. Interesterification may be accomplished by chemical or enzymatic processes. Chemical interesterification is a process by which fatty acids are randomly distributed across the glycerol backbone of the triglyceride. This process is carried out by blending the desired oils, drying them, and adding a catalyst such as sodium methoxide. When the reaction is complete, the catalyst is neutralized and the rearranged product is washed, bleached, and deodorized to give a final oil product with different characteristics than the original oil blends. The second process is enzymatic interesterification. This process rearranges the fatty acids, which can be position specific, on the glycerol backbone of the triglyceride through the use of an enzyme. Higher temperature will result in the inactivation of the enzyme. After interesterification, the oil is deodorized to make finished oil products. Now, let's talk about some of the processing aids used in processing of fats and oils. First, mode of removal of sodium hydroxide is water wash and neutralization. Number 2, mode of removal of carbon is filtration. Number 3, mode of removal of nickel is filtration. Number 4, mode of removal of sodium methoxide is acid neutralization. Number 5, mode of removal of phosphoric acid is bleaching. Number 6, mode of removal of nitrogen is diffusion and vaporization. Number 7, mode of removal of silica hydrogel is filtration. Now, the role of additives in processing of fats and oils. Number 1, tocopherols, BHA, BHT provide antioxidant activity and also retard the oxidative rancidity. Number 2, carotene enhances the color of the final product. Number 3, dimethyl polysilicoxane inhibits oxidation tendency and foaming of fats and oils during frying. Number 4, diacetyl provides the buttery odor and flavor to fats and oils. Number 5, lecithin acts as water scavenger to prevent lipolytic rancidity. Number 6, citric acid prevents metal catalyzed oxidative breakdown. Number 7, polyglycerol esters act as crystallization modifier and inhibitor. Now, we'll shift our focus on to the next important point in fats and oils, that is reaction of fats and oils. The first important reaction of fats and oils is hydrolysis of fats. Like other esters, glycerides can be hydrolyzed readily. Partial hydrolysis of triglycerides will yield mono and diglycerides and free fatty acids. When hydrolysis is carried to completion with water in the presence of an acid catalyst, the mono, di and triglycerides will hydrolyze to yield glycerol and free fatty acids. With aqueous sodium hydroxide, glycerol and the sodium salts of the component fatty acids, that is soaps, are obtained. Moving on to the next step, that is oxidation of fats. Number first, autooxidation. Of particular interest in the food arena is the process of oxidation induced by air at room temperature, referred to as autooxidation. In autooxidation, oxygen reacts with unsaturated fatty acids. Initially, peroxides are formed which may break down into secondary oxidation products, for example, hydrocarbons, ketones, aldehydes, and smaller amounts of epoxides and alcohols. The result of the autooxidation of fats and oils is the development of objectionable flavors and odor characteristics of the condition known as oxidative rancidity. When rancidity has progressed significantly, it becomes readily apparent from the flavor and odor of the oil. Coming to the polymerization of fats. All commonly used fats, and particularly those high in polyunsaturated fatty acids, tend to form larger molecules known broadly as polymers when heated under extreme conditions of temperature and time. Under normal processing and cooking conditions, polymers are formed in insignificant quantities. Although the polymerization process is not completely understood, it is believed that polymers in fats and oils arise by formation of either carbon-to-carbon bonds or oxygen bridges between molecules. When an appreciable amount of polymer is present, there is a marked increase in viscosity. Now, shifting our focus to the reactions during heating and cooking. Glycerides are subjected to chemical reactions, that is oxidation, hydrolysis and polymerization, which can occur particularly during deep fat frying. The extent of these reactions, which may be reflected by a decrease in iodine value of the fat and an increase in free fatty acids, depends on the frying conditions, principally the temperature, aeration and duration. Frying conditions do not, however, saturate the unsaturated fatty acids. Although the ratio of saturated to unsaturated fatty acids will change due to degradation and polymerization of the unsaturated fatty acids. The frying operation also results in an increase in the level of polar compounds, that is mono and diglycerides, free fatty acids and other polar transformation products formed by frying or heating of foodstuffs in the oil. The smoke, flash and fire points of a fatty material are standard measures of its thermal stability when heated in contact with air. The smoke point is the temperature at which smoke is first detected in a laboratory apparatus protected from drafts and provided with spatial illumination. The temperature at which the fat smokes freely is usually somewhat higher. The flash point is the temperature at which the volatile products are evolved at such a rate that they are capable of being ignited but not capable of supporting combustion. The fire point is the temperature at which the volatile products will support continued combustion. The degree of unsaturation of oil has little, if any, effect on its smoke, flash or fire points. Oils containing fatty acids of low molecular weight such as coconut oil, however, have lower smoke, flash and fire points than other animal or vegetable fats of comparable free fatty acid content. Oils subjected to extended use will have increased free fatty acid contents, resulting in a lowering of the smoke, flash and fire points. Accordingly, used oils freshened with new oil will show increased smoke, flash and fire points. Finally, coming to the importance of fats and oils. Fats and oils are recognized as essential nutrients in both human and animal diets. Nutritionally, they are concentrated source of energy, that is 9 calories per gram, provide essential fatty acids which are the building blocks for the hormones needed to regulate bodily systems, and are a carrier for the oil-soluble vitamins A, D, E and K. They also enhance the foods we eat by providing texture and mouthfeel, imparting flavor and contributing to the feeling of satiety after eating. Fats and oils are also important functionally in the preparation of many food products. They act as tenderizing agents, facilitate aeration, carry flavors and colors, and provide a heating medium for food preparation. Fats and oils are present naturally in many foods such as meats, dairy products, poultry, fish and nuts, and in prepared foods such as baked goods, margarines, and dressings and sauces. That's all about fats and oils. Hope you have understood it well. Thank you and goodbye.